So if you have been doing AL, this is Unit 8, and AL is going to be Chapter 18, and again, it's optional, huh? Okay, so a formula equation is our molecular equation. It gives us overall what is going on, what the reaction is, but it doesn't tell us anything else. We just see it as compounds. We learned in Unit 2 that we have our solubility rules, and when we have our solubility rules, we further take what we know and we break it down into our complete ionic equations, where we have our aqueous nitrate, or silver nitrate, and your aqueous silver chloride. Going to your solubility rules, you know that silver chloride is a solid, so we get our solid here, and then we have our two spectators. So if you don't remember your solubility rules, go back and review them. Once you do that, you get your overall equation, your net ionic equation, which just shows what's actually going on. We have silver chloride and silver and chlorine ions, and it gives us silver chloride. No spectators in there. Everybody good? Okay, so this right here just, again, is showing you have our formula equations, what we're used to seeing, breaking it down into its component parts, and then we get to our net ionic equation by crossing out whatever occurs on the any free element that is by itself has an oxidation state of 0. Oxidation states of your monatomic ions is just that charge. Oxygen is a -2 in covalent compounds, hydrogen's a +1, and fluorine's a -1.
And a monatomic ion is just where it's just
Like, not like a polyatomic, so it's just like Ki.
So regular, non-covalent?
Yeah.
Oh, that's just the three.
Just a regular, oh my gosh, ionic bond, just between two atoms. So the sum of your oxidation states has to equal 0, unless you have something like a polyatomic ion. Then the sum of your oxidation states has to equal that charge of whatever's on that ion. So knowing these 7 rules will help you determine oxidation numbers. So we're going to practice some. Find the oxidation states for each of the following elements. And I'm just going to do the first and second one. So oxygen is always a what? -2 when it's with something. So oxygen is a -2, and there are 7 of them. So that's a total of -14. Potassium has an oxidation number of whatever its charge is, which is +1. And there's 2 of them for a total of +2. So chromium, there are 2 of them. So whatever it has to be a number where overall equals 0. So what does chromium? It has to be not -6. It has to be a +6 to give me a +12.
And hypothetically speaking, if this compound was like in parentheses to an Na2, then instead of going to 0, we would try to make it to
Yep, that's what we're about to do to
And so, like,
carbonate.
-14 conventional or oxidation states.
Hmm.
Like -14, 12, and 2 of those oxidation states, or is -2 and -6 oxidation?
So -2 is the oxidation state of one oxygen. The total oxygen would be -14. Oxidation state for potassium is a +1, but overall is a +2 because we have 2 potassiums.
So since it's asking for the specific elements, do we need to write it to the side? Like O would be -2, K would be +1.
Yes.
N would be 6.
Yes. Yes.
These charges are all just from the
Except for chromium. Oxygen and potassium came from the chart. Chromium did not.
why did we know because it's a transitional metal.
It's a transition metal, but it is I always look at the first one and the last one, and then that helps me find out the middle one.
So you most likely won't know the
You most likely won't know the middle. You have to do the math to figure out the middle one. So let's do carbonate. CO3 with a -2 charge. So each oxygen has a -2 charge, and there are 3 of them for a total of -6. Carbon, there's only 1 of them, but whatever it equals, when I add them together, it has to be a -2. So that means carbon has to be what? A +4. In this circumstance, it's true, but not always. Because it tells me it's a polyatomic ion.
Oh.
Okay. So do we need to do one more before? Let me look at one I want to do. Let's do KMNO4. So potassium permanganate, oxygen is a -2 for a total of -8. Potassium is a +1 for a total of +1. So Mn has to be what? To get me to 0. +7. Okay. So some characteristics of redox reactions is we have a transfer of electrons. They may occur to form ions. Oxidation increases in the oxidation state. So what happens is our oxidation number goes up. Whereas in reduction, we have a decrease in oxidation state, which means that our oxidation number goes down. If something is oxidized, whatever gets oxidized, it's called the reducing agent. If you get whatever's being reduced, it's called the oxidizing agent. Don't focus on that so much as knowing what's being oxidized and what's being reduced. Okay? Gains electrons. So if you're oxidizing, you're losing an electron, so that means you're a donor, whereas the other one's an acceptor. Okay, and also metals tend to oxidize. So metals tend to be oxidized, like rust. Okay, so we're going to do one of these. Which of the following are oxidation reagents? I don't care about the reactions. I don't care about the oxidation agent and reducing agent. First thing I want to tell you is all synthesis reactions, decomposition, single replacement combustion reactions are redox. The only thing that usually is not a redox is your double replacements. So if we were to do this real quick, all my free elements have a oxidation number of 0. Hydrogen's charge is a +1, chlorine's a -1, zinc's a +2, chlorine's a -1. So zinc goes from being a 0 to a +2. Hydrogen goes from being a +1 to a 0. So hydrogen is reduced and zinc is oxidized.
Why does zinc start at 0?
It's over here. It's a free element. Free elements have a oxidation number of 0. If we look at the C, copper, chlorine's a -1, which means copper has to be a +1 here. Over here, chlorine's a -1, but copper now is a +2. So what happens is copper is both, it goes from being a +1 to a 0, but it also goes from being a +1 to a +2. So in this situation, it's both, one of the coppers is being oxidized and the other one is being reduced. So you have both going on there. So copper chloride is both your oxidizing and reducing agent. Everybody good with that? Am I going too fast? Sorry. A lot of it's going to be like review. I'm just going to go and get into it, and then if you need to go into looking at the notes, then you can go to the notes. So before we get started, here's some assigning oxidation numbers that you can go in there and play with that if you want, but I'm not going to lecture over that. Review of terms. Well, our whole unit's electrochemistry, which is the interchange of chemical and electrical energy. So how is energy flowing? Oxidation, reduction, redox reactions, transfers of electrons. Oxidation is loss. And if you are oxidized, you are the reducing agent. And reduction is gaining. And if you are reduced, then you are the oxidizing agent. So those are some terms to review. So now I'm going to go into half reactions, a redox reaction, to see what is actually going on. If you will look, starting at 7 to page, 9, I'm going to kind of hit on those points, but I'm not going to read you those slides. You can go back and look at them. Yes, Shreya?
If oxidation is a loss of electrons, then how is oxidizing agent electronic set?
The oxidizing agent is the electron, because reduction and oxidizing agent go together. So the one who loses the electrons is giving it to, so it's the agent. It gives those electrons to the, it loses the electrons, and when it loses the electrons, it gives it to somebody and that is the oxidation agent. So the loss of electrons goes to the oxidizing agent. If you're reduced, what is being reduced is taking those electrons in. So the reducing agent is donating those to the person that's taking the element that's taking the electrons in. Like I said, don't focus too much on the agents. Focus on the oxidation and the reduction. So we're going to talk about half reactions. So a half reaction is where we're going to split it into two halves. One involving oxidation, the other involving the reduction. And we're going to see what happens. And I'm just going to go ahead and write my equation. I have this blank page here. So if you want to write off to the side or something, we're just going to work one problem, and I will talk about the steps as we go along. So we are going to take MnO4 minus and iron 2 plus, and we are going to get Mn2 plus plus Fe3 plus. So that's what we're given. You will also be told if it's an acidic solution or a basic solution. Right now we care about acidic solutions. So the very first thing when I tell you to balance these half reactions, what you need to do is take your reaction and half it into its parts. So MnO4 goes to Mn2 plus. I've taken those out. That's our overall goal. That's my goal to get to. So I've kind of just skipped that, and we're going to go back to it. So Fe2 plus goes to Fe3 plus. So we have a saying that is, all oranges have citrus energy. And that just tells me how we're going to balance these electrons, or balance these equations. So all. So when you see all, what I mean is to balance. So you have all, and then you have oranges have. So A is balance everything except for oxygen and hydrogen. And then oranges stands for oxygen, have stands for hydrogen. So if I look at the very first reaction, MnO4, I need to balance my MNs. And it looks balanced to me. Next, we're going to balance the oxygens. I have 4 oxygens on the reactant side. I need to get 4 on the product side. So to get 4 on the product side, I am going to add water. And I've added 4 waters because I need 4 oxygens. Now when I added that water, I have some H's. So now I need to balance my H's. So I'm going to add 8 H pluses to the other side. So I have my oxygens and I have my hydrogens. Next, citrus energy. So this is the charge of electrons. So look at your charges. Overall charge on the reactant side is what? We have 8 positives and 1 negative. So the overall is a 7 plus. If I look on the other side, I have a 2 plus and a 0. So the overall is a 2 plus. So where do I have to add electrons so that I can get these charges to be the same? We are going to add it. Hold on. I've lost my page. we're going to add we have 7, so I need to get down to 5, so I'm going to add 5 electrons over, or I need to get down to 2. So I'll add 5 electrons on the reactant side. Now you go and you deal with the next one, iron. So you have all your iron. Iron looks to be balanced to me. So now we have to do oxygens. There's no oxygens, so that's good. And then you do your hydrogens, and there's no hydrogens, so that's good. So our next goal is to do our electrons. So I have a 2+ and a 3+. So I'm going to add 1 electron to the product side. Now, when I do this, redox is a transfer of electrons. So the amount of electrons being transferred has to be the same. So if I have 5 electrons on the reactant side and 1 on the product side, I've got to get those to be the same. So I am going to multiply the whole half reaction by 5. When I multiply it by 5, now I have 5 FEs here, and 5 electrons. And we go back and we're going to clean it up. So, if it appears on the reactant side and it appears on the product side, we can cross it out. It goes away. We have 8 hydrogens plus MnO4 plus 5 Fe2+, and we get Mn2+ plus 4 waters and 5 Fe3+. And that should match what we have at the top of page 7. Oh, sorry, I missed the negative sign right there. Yes.
Okay. A, what's the point of splitting it apart? Because they're going to give us this equation, right? The top equation.
Mm-hmm.
So what is the point of splitting it apart and then putting it back together identically?
Yeah.
What is this
We
prove?
broke it apart and then put it back for no.
But it's not exactly what's up at the top. If you look on page 7, I've given you our overall goal. But what will be given to you is what's at the very top of what I've written on our slide.
Okay, so they won't give us this. They'll give us the reduction oxidation. Okay.
They're going to give you this right here.
That's what threw us off because we did.
That's all you're going to get.
Okay.
That's all you're going to get on your homework.
So what was the point of multiplying it?
You have to have equal number of electrons on each side. All right. As you're doing this, you'll notice, oh, I'm adding water over here, and then I'm adding water on this other side on the next one. So it should be balancing each other out. So let's do one more. Go to page 9. There's a flow chart right there for you, if you need it. And now we're going to do this one on page 9. I'm just going to, there's whole steps in there. I'm just going to do it in one little part right here. So I have this equation that we're being given. First thing we need to do is split it up.
So on our homework, they will.
That's what you'll get on your homework, like that. And then you need to split it up. Next, you need to balance all except for oxygens and hydrogens. So I need a 2 there. Once I've put that 2 there, now I need to work with my oxygens. So I need to add water. So I need to add 7 waters. After I've added 7 waters, now we need to look at our hydrogens, and we need to add 14 H pluses.
To make the charge equal to 0, the overall charge?
No, I haven't done that yet. I have to just get to balance out my H pluses. Because I added water over here, now I need to get hydrogen over on the other side.
Why do we not add H2O?
Because we're working with an acidic solution. So my acidic solution comes from that H plus.
So this H plus is the positive charge.
Yes. Then you go and you figure out how many electrons do we need to add and where. So we have an overall positive 12 charge right here. And on the other side we have a positive 6 charge. So I need 6 electrons on my reactant side.
What's the charge equivalent? Is that what we found that right?
What's the charge of what? Okay. Go to S. S is balanced. Now we deal with oxygens. So we add how many waters? 1 water. So oxygens are balanced. Now we add hydrogen. So how many hydrogens do we need to add? So we add 2 H pluses. And now we need to take care of our charge by adding electrons. So we have a -2 and we have a 0 on the other side. So we need to add 2 electrons. Yes.
Why did you add the water on the left side?
Because I had to get my oxygens balanced. I have 4 oxygens on one side and 3 on the other. Yes.
How come we didn't put H2 and instead we put 2H?
That's what we just talked about. We said H2, this is an acidic solution, so where do I get acid from? H plus.
If it was a basic, would we be adding?
We're going to talk about, we're going to add another another step in a basic solution. Okay, so now we need to multiply. We have 6 electrons and 2, so we need to multiply. We need to multiply our bottom one by 3. So everybody gets multiplied by 3. Which means that we now have 3 waters, 3 SO3s, 3 SO4s, 6 hydrogens, and 6 electrons. Once you've done that, you come back and you clean it up. So my electrons go away. I have 3 waters on this side and 7 over here. So we have 4 left, and that goes over here. So 4 H2O. I have 14 hydrogens right here, and I have 6 over here. So these 6 go away, and that leaves me with 8 hydrogens. And I have Cr2O7 plus 3 SO3 2 minus. And then we have 2 Cr3 plus 3 SO4 2 minuses. And you come back and you make sure that everything has the same charge. So on the reactant side we have 8 and 6, so we have a +2 charge total. And we want to go to the other side and we have a, where did we go wrong? Oh, I see where it is. 2 minus. So we have an overall 0 charge. It should be 0, right? I have a 8 and 8, and it's 0. I have 8 hydrogens.
But I thought they're by themselves, their oxidation would be 0.
8. If it's an H plus, it's a plus. So you go to page 11 and see, did we get it right? And it looks correct to me. So this is all those steps going through there. You want to go do one more acidic solution before we go to basic?
Sure.
All right, so let's do practice number 1. So page 12. So this time, break it up. So you guys work on this. You work on this yourself. And you should know the first step is break it up.
So there's like no charge. It's like SA, bridge is doing that charge is 0.
Mm-hmm.
So when you get ready solution,
I multiplied the whole thing by 16.
It's like,
Oh my
go
gosh.
through it
um,
once very slowly. I do not get this one so hard. I get breaking it apart, and then I get really lost.
Okay. So very first thing was broke it apart. Once you break it apart, you go and you balance everything except for oxygen and hydrogen. So the first thing I did was I balanced the sulfurs by putting an 8 there.
Okay. And I guess that's where I'm using subscript.
Then I balance my oxygens, no oxygens, hydrogens, no hydrogens, my charge. I have a charge of 16, negative 16 right there. I have a charge of 0 right here. So to get to negative 16, I need to add 16 electrons.
Oh, so you want the two opposite sides to equal each other. Okay, I just keep thinking like canceling out to 0. But that's not right.
No, they have to equal each other. So then we go and we do the next one, the NO3s. We balance the N's, which they are. You balance the O's. So by balancing the O's, we need to add water to the product side. Now my O's are balanced. Now I need to go balance my H's. I have 2 H's on the product side, so I put 2 H pluses on my reactant side. And then I go and look at my electrons. I have no charge on the product side, but but I have a charge of
Why?
+1 on the reactant side.
So the H is just not as one?
No, it's 2 plus that 1, so that's a total of +1. And I have no charge over here. So if I have a charge of +1, I add 1 electron to get me to a 0 charge.
And you can't add protons.
We can't add protons. So then next thing, what we do is we multiply. We have to have the equal number of electrons in both half reactions. So both of them gets, so the bottom one gets multiplied by 16 throughout the whole equation. And then you come back and clean it up. If it appears on the reactant side and the product side, then you get it balanced out to, if there's 16 electrons on one side and 16 on the other side, the electrons go away.
And these you can't flip, right?
No, we're not flipping them right now, no.
So once they
Yes.
even electrons, they cross out.
Huh?
So once they even electrons, like once you have 16 on one side and once you have 16 on the other.
They go away, yes.
So this is our final one.
That's your final answer.
So the charge.
So it can be like this. Just a, is it just a
When we're talking about electrochem, yes.
The charge on both sides when you don't have to equal 0.
No, they don't have to equal 0. They just have to equal the same thing.
Like on this one, they equal 0.
On the
Like the very.
on the second one, it equals 0.
Is it
but-
supposed to? That's my question. Like,
It equals 0. Well, there's I have a +1 charge here, and I have a 0 charge over here. So I can only add electrons.
I'm talking about like at the very end.
At the very end, oh, the electrons cross each other out. Yes, the electrons cross each other out. They go away.
I'm talking about like.
They're being transferred.
like on final chemical equation?
There should not be any electrons.
Right, no, but like
Yeah,
this
but
charge,
charges.
does the reactants have to equal 0, the products have to equal 0?
No, they just have to equal the same charge.
Okay.
So the only things that got canceled was the electrons.
Yes. So you have a charge of 16 minus, 32 plus, 16 minus. That is 0. On the other side, we have 0. It doesn't always work out that way.
Okay.
Okay. Okay, so then the next one, we are going to go to do a basic solution. So basic solutions, we're going to set it up just the same way. We're going to break it in two. So MnO4 minus and MnO2. And then we have I minus and IO3 minus. MNs are balanced. So go to your oxygens, and we add 2 waters. Next, go to your hydrogens. I need to add 4 H pluses. And then look at your charge. Wait, I'm wrong. Wrong. I did that a while ago too. This needs to be a 4.
Oh, right, because we, no.
No, wait.
It's 2.
It's a 2?
It has to total 4 oxygen, right? Yeah.
Oh, I'm doing the wrong problem. Yes, you're right. I'm doing the wrong problem. Oh my gosh. Okay, back where we were.
I know, I made like a whimpering dog sound.
Okay, so we have 4, we have a positive 3, and we have a 0 on the other side. So we need to add 3 electrons.
What should affect the charge?
Yes. You multiply that. So 3 electrons is 3 negatives. E.
Oh, okay.
4,
So 0.
yes. Oh, for this one, we're trying to get to 0. So my I's are balanced. I go to my oxygens. I have 3 oxygens, so I need 3 waters. Now I have 6 hydrogens, so I add 6 hydrogens on the other side. So I have an overall -1 charge on 1 and a 5 charge on the other. So that means we need to add how many electrons? So we add 6 electrons. I have 3 electrons and 6 electrons. So I need to do what? So we're multiplying the top one by 2. So this turns to 6, this turns to 8, this is a 2, this is a 2, and this is a 4. And now you go and clean it up. So my electrons go away. I have 8 hydrogens, but I have 6 on the other side, so that gives me 2 H pluses plus 2 MnO4 minuses. I have 3 waters on one side and 4 on the other, so my waters go away, and I'm left with I minus.
Why did water go away?
Because I have 3 on one side, so water goes away on this side. There's still 1 left over on the other side. So 3 of the waters go away. So then that leaves me with 2 MnO2 plus, or MnO2 plus a water plus IO3 minus. Now we are in an acidic solution. My thing says it has to be a basic solution. So to get to basic solution, for me to get rid of that acidic part, this H plus part right over here, I need to add OHs there to counteract it to make water. So I need to add 2 OH minuses to both sides.
Are we doing it both sides for the sake of it remaining equal?
When I add it to both sides, what we're left with is we now have 2 waters here, and we have 1 water over on the other side. So to further clean it up, this water goes away, and we're left with 1 water on the reactant side.
OH is combining with that one water makes it.
2 H pluses plus 2 OHs give me 2 H2Os.
On the right side.
And I have 1 H2O over here.
Factoring it out.
I still don't get it on the right side. Can you, like, write it off?
What do you mean?
She didn't add the 2 H's to the waters. They're there. So like
So it would be red 2 MnO2 plus
What?
IO3 minus plus 2 OH.
Let me write the overall. 2 MnO4 minus plus I minus plus H2O gives me 2 MnO2s plus IO3 minus plus 2 OH minuses. So my overall charge is a negative 3 on both sides. And now I'm not in an acidic solution. I've added that OH, and now I'm in a basic solution. That's the answer.